everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. It comes from an educator site from the SAT. So, spoiler alert, this may be on a Blue Book test. Okay, we have an equation, 48x minus 72y equals 30y plus 24, and ry equals 1/6 minus 16x. In the given system of equations, r is a constant. If the system has no solution, what is the value of r? So this is a very common problem. It's a problem where you have to find the parameter in an equation. The SAT people love this type of question, so you'll be almost guaranteed this to be on your test. I think we have to put the x's and the y's on the same side, don't we? So we are going to annotate, and we are going to do a 48x. Now we subtract 30y, so that's minus 102y is equal to 24. We do a little check to make sure that's right. 30 minus 30 minus 72. Yeah, okay. Now we have a positive 16x because we're moving the 16x to the side, so we're adding a 16x on this side plus ry.
Wait. Why don't you just convert
Is equal to 1/6.
the first equation to form similar to the second?
Really? Go about the first equation. Yeah,
No, take the first equation.
Yeah.
And get
the
left-hand side to be a constant times y, and the right-hand side to be a constant plus a coefficient times x.
I don't know. I sort of like this way more. So you could see that if you multiply this by 3, you get a 48x. So we're definitely going to need that. We're definitely going to need that because we want to have the coefficients of the x and the y's to be the same. So if we multiply this by 3, we get 48x plus 3y.
3ry.
3, yeah, I was going to add that. 3ry. Yeah, we need that coefficient. We need that parameter in there. Equals a half. So it looks like 3r is going to have to be negative 102. And that's the only way it's going to happen. Yeah, that makes sense. Yeah, for 3r to be equal to negative 102. For these two coefficients to be the same. So that's it. That should do it. That'll give us the answer. So of course calculators allow it. You really should have your own calculator because you don't want to waste time opening up Desmos. So it's 102 divided by 33. So 102, divided by 3 is 34. You could probably even do that without a calculator.
Negative 34.
Oh my God, Seth. Oh. Yeah. That's bad. That happens too many times to people. Everyone. I'm sure that happened to you too in your life. You drop the negative sign. No matter how careful you are, negative signs are insidious. Oh, I may have gotten that wrong. Oof. So how are you going to avoid that in practice? Seth?
How do you you look at the equation, and you see that to solve for r, you divide the right-hand side by 3. And since you're looking at the equation, you see that the right-hand side is right there, printed, minus 102.
Yeah, the problem is I was looking at my calculator.
Well, you could type into the calculator, minus 102, divide by 3.
I know. The other way to avoid this is to double check. Is to proof, which you really should do anyway with everything English when you're writing anything in English or math, is proofread. I proofread this to make sure the negative 102 is right, but I didn't proofread this. Maybe I would have if you didn't point it out. It's possible I would have proofread it, but probably proofreading is a good way because you're all going to make stupid mistakes. So I don't know. I didn't mind moving everything to. I basically wanted to get everything in this form that I'm familiar with. as opposed to bringing it into a form not as familiar, which is the form they gave. So you would have suggested to use this as the main way of doing, use this as the template and turn equation 1 into
Well,
equation
that's because the term with R is all by itself on one side.
Right.
And the problem is to find R.
But then you would, oh, I see. But then you have a problem moving the 48 to the other side, and that you may forget and may not make it a negative 48x.
Ah.
It's possible. It's possible. If you do this one, this is, I don't know how many fewer. I mean, here here it's pretty clear you're going to do a negative 30. It's hard to drop it. And here there's a negative 16x, so you're going to add 16 to this side. But it's a little dangerous to subtract 48x. You may drop that negative sign. Some people drop negative signs. But you know what it is? It's personal choice. I think it's personal choice. But the main idea is that if you have two equations, ax plus by is c, and dx plus ey is f, if you want to have a situation where the equations have either infinite number of solutions or infinite number of solutions or no solutions, then what is this? Oh, this is a d. Then a would have to be d, and b would have to be e.
No.
And c.
No. A has to be a multiple of d, and b has to be the same multiple of e.
Right. Okay. No. Okay. Then assuming these are in simplest form.
So write it out. A equals dm, and b equals em.
And m is non-zero integer.
Yeah.
No, m is a non-zero number.
Yeah.
M is non-zero.
And then what you have is you have an infinite number of infinitely many solutions. If C equals Fm, and you have no solution if C is not equal to Fm.
Right. That's right. That's the general solution. That's the general way of doing it. Yeah. So here we didn't even check if. Well, here we know that a half doesn't equal 24. So those numbers are different. A half and 24 are different. So.
Well, this condition about the a equals dm and b equals em, that condition is given a name, and that name is the left-hand sides are linearly dependent.
Yeah. So let's just give an example of that. If you have x plus 7y is 2, and then 4x plus 28y is equal to 8, then you have this condition where m would be 4. And this would have infinitely many solutions, because 2 equals 4 times 4 to 8. 8 would be 2 times 4. Right. So, okay, any other thoughts before we ask the questions? Always, no other thoughts? Okay, so does a calculator help? Maybe. But you have to be careful. Like, I used a calculator when I probably shouldn't have. If I didn't use a calculator, there's a better chance I would have not have made a negative sign mistake. Maybe you would do 3r is negative 102. Divide both sides by 3, and then you would see this.
Okay, well, if you're going to divide, do that division. I wonder, would it be better to type into the calculator negative 102 divided by 3? Or to avoid putting in the extra keystroke of negative and do 102 divided by 3, and then remember that the answer is the negative of what comes out.
I think people have to this is a danger point for everyone taking this test. And I think when you're practicing, you should be very aware of this and come up with a way that works for you. Because some people may prefer to put the negative sign in, and some people may prefer not to put the negative sign in and remember to answer it later. But I think it's also important to double check and proofread everything. Notice that I saved a little. Notice what I did here. I made, instead of using calculator, negative 102 is negative 99 minus 3. And now you can do this. This is negative 33 minus 1, which is negative 34. It's doing it using not a calculator. By splitting the 102 into two numbers that really are divisible by 3. I mean, 102 is divisible by 3, but splitting it into numbers where it's more obvious what the answer is. 99 divisible by 3 and 3 divisible by 3 are easier than 102 divisible by 3. So anyway, if you use a calculator, be careful. And then, I don't know if you really need a calculator to do negative 72 minus 30, but if you do, you do. Starting with a guess, there's no guess, so you can't do that here. How does this differ from a school test? It could be on a school test. Is there a pattern to this question that makes it necessarily easier? Can you take that pattern that you could take advantage of to do the problem faster? No, there's no pattern. I don't think so. And the most important question is, what are the SAT people? What did the committee want to see if you knew how to do? And it's clear that they want you to understand the conditions where a set of two linear equations has either no solution or an infinite number of solutions. So it's very clear that that's what they're targeting to see if you understand those conditions. And we talked about those conditions, but the coefficients of the variables need to be the same for either no solution or infinite number of solutions, and then it depends on what that constant is on that side of the equation. Depending on how you write it, of course. You write it in the standard form way.
What
do you think?
I don't know.
You don't know?
So let's move on to
let's look
compare their answer.
Of course.
And then the four questions?
No, we just did the 4 questions.
Oh, we did.
Yeah. But by the way, when you say calculator, going to Desmos and graphing this thing, no, of course it doesn't. Ooh, Desmos, there is a parameter in Desmos, but forget it. That's a great little method, but it's probably not practical. But in Desmos, I believe you can add a parameter, and then you can change the parameter to C, but that just doesn't make sense. Okay, clear all drawings. And they rated this question hard, by the way. Okay, so let us see. Negative 34. And a pretty big answer. Okay, wow. The answer is 34. System validity, has no solution if the lines represented are distinct and parallel. They're in standard form. That's what we talked about. Oh, yeah, this is what you said, Seth. If x and y in one equation are proportional, the corresponding coefficients in the other. To the corresponding coefficients in the other. Okay. If the first equation is given in standard form, that's what we did. The second equation is done the same way. Yeah. Okay. So the coefficient is 3. Oh, so yeah, someone may need to do that on a calculator. What's the relationship between 48 and 16? It's 48 divided by 16, but hopefully everyone has enough experience to know that right off the bat. But maybe not. But you would then divide that. It's 48 by 16 to get that coefficient. The coefficient is 1/3. Oh, so what they did is they multiplied by 1/3 they multiplied the first equation, 48 minus 102x, by 1/3, and what I did is I multiplied the second equation by 3. It's easier to multiply by 3 than it is to but then ultimately I had to divide it. Here they didn't have to. They just multiplied by 1/3.
Yeah.
That's a little safer.
Their way is okay.
That's a little safer, actually, because it may be easier in your brain to notice. Well, I'm saying my concern is the negative sign. The question is, it would be nice to know. They don't tell us. We don't know how many people got 34 and just drop the negative sign. But again, it's all personal preference, whether you multiply this by a third or you multiply this by 3. And it really is personal preference. But be aware of this potential negative sign mistake. We try to share mistakes with all of us. We don't see the mistakes you make, but you see the mistakes we make, and I make particularly. Sometimes Seth makes mistakes, and negative sign mistakes are the most common mistake made in algebra. Be aware of that. So I guess that's it. I'm Joel. I have a PhD in mechanical engineering. My brother Seth is a PhD in math. We try to meet every day to do an SAT math question or for different ways of doing it. Give you insights. Go over possible mistakes you can make. Go over the main idea of the question. And hopefully we give you different approaches. Here there really wasn't much of a different approach to it. The explanation wasn't bad. And I think that's it for today. Please give us comments on our videos. Please dislike our videos. We take all the comments very seriously. And if you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. That's it. Anything else?
No.
I think we're done for today. Great. Okay,
That's
everyone.
it for today.
Have a great day. Take care, everyone. Bye.
Okay.